This lesson covers how to partition a directed line segment. So first of all, the definition of a directed line segment is kind of the same as a vector. A directed line segment has length and direction. So the order of the letters matter. For example, if I have a directed segment BA, if I say directed segment BA, that means it starts at B. So that's our beginning point, and that's going to matter when I show you the process for how to divide up a line segment. It starts at B, ends at A. And that's because the B is the first letter that you see. So the beginning point is the one on the left, the end point is the one on the right. Partitioning basically means dividing this line. We're going to divide it into two parts, but it's not going to be 50-50. So partitioning is dividing a segment into two parts. Using a given ratio, so using some kind of a ratio that we convert into a scale factor. So I'm going to kind of write a couple steps down here, then I'll just work through examples, because the easiest way for you guys to get this is to see some examples. The first step here. So the first step is to determine the scale factor. And you do that from the ratio that you're given. So in all these problems, you're going to be given a ratio. And the scale factor is going to be the first number that you're given, and then the sum of the two numbers. So for example, if the ratio that you're given in the problem is 2 to 3, two parts, that means you're dividing up the line, 2 parts on one side, 3 parts on the other, so you have a total of 5 parts. So what that means is for your scale factor, the scale factor is going to be the first number over the sum. So your scale factor is 2 over 5, not 2 over 3. And then what you do, you start at the first coordinate, and we take the x's and the y's separately, and I'll show you that in the example in just a minute. I forgot the word add in there. You need to add the scaled distance. And by scaled distance, what I mean is the total distance would be the difference between the two numbers. So let's say for the x's, the total distance is going to be x2 minus x1, and you're going to multiply that by the scale factor. If that scale factor were something like 2/5, then you would multiply the whole thing by 2/5. And then finally, your answer is going to be a coordinate. We're looking for an x and a y coordinate that is that certain distance away from the original, from the starting point of your directed line segment. So I'm going to walk through an example with these 3 different ratios. Given line segment AB, that means A is the beginning, B is the ending. You have your 2 coordinate points. We want to divide that line segment, first of all, in the ratio of 1 to 1. So what we do is we find our scale factor. So our scale factor in this point is going to be the first number 1 over the sum of the 2. So our scale factor is 1/2, which basically means you're dividing the line in half. So here's how we do this. I'm going to find my x coordinate, and then I'm going to find my y coordinate. For the x coordinate, you start with, since the line starts with A, you start with this A value, which is 3. That's my beginning. So I have 3. To that, I'm going to add half the entire distance, because my scale factor is 1/2. So the entire distance there is going to be 7 minus 3. It's the difference between the two x values, so this is not complicated. So that gives me 3 plus half of 4, 3 plus 2, so my x coordinate is 5. We do the same thing for the y. I start with 2, and to that I'm going to add half the total y distance, which is 5 minus 2. So that's 2 plus 1/2 of 3. That's going to be 2 plus 1.5, so that's 3.5. So my answer is 5, 3.5. That's the coordinate that divides that line segment into a ratio of 1 to 1. So for the next two examples, the only thing that changes is the ratio. Here the ratio is going to be 2 over the total 3. I want to be 2/3 of the way across. So x, again, the 3 stays the same. The only thing that changes is that scale factor. Everything else stays the same. I have 3 plus, this ends up being 8/3, and when you add that together, it's 17/3. For my y, again, the only thing that changes is the scale factor. 2/3 times 5 minus 2, so that's going to end up being 2 plus 2, which is 4. So this answer is 17/3 and 4. Same thing for the third example. The only thing that changes is the scale factor. So the first number is 3, the sum is 5. So again, x, for my x value, it's going to be 3 plus 3/5 times that 4, and you end up with 27 over 5. For my y value, it's still 2 plus 3/5 times 3, and you end up with 19 over 5. So that answer is 27 over 5 and 19 over 5. For the next example, you have segment AB is drawn from A to B. So A is the beginning point, B is the end point. Our ratio is 5 over 2. So that means our scale factor is going to be 5 is the first number. The sum is 5 plus 2, so it's 5 over 7. And the process is the same. We start with the first x value, which is 0. To that, we're going to add 5/7 of the entire distance, which is -7 minus 0. It's always end minus beginning. Don't reverse it. So this ends up being 5 over 7 times -7. So that's -5. For my y value, I start at 10. To that, I'm going to add 5/7 of the total distance. This is -4 minus 10. So that's 10 plus 5 over 7 times -14. Whoops, -14. That's 10 plus -10, so that's 0. So that answer is -5, 0. We can also use a graph to help us out. I want to find the point Z so that AB is in a 1 to 3 ratio. A is the beginning, B is the end. My scale factor is going to be the first number over the sum. 1 plus 3 is 4, so I want to go quarter of the distance. You can count squares if you want to, or I can just do the formula again. Either way, it should all work out when you're done. I'm going to write down the coordinates. A is at -1, 9. B is at 7, -3. So again, my x value, I start at -1. I'm going to add a quarter of the total distance, which is 7 minus a -1. So that's -1 plus 8 divided by 4 is 2. I should end up at +1. For y, I start at 9, and I'm going to add a quarter of the total distance. So that's 9. It's -3 minus 9. It has to be end minus beginning. 9 plus 1/4 of -12. These numbers are working out nice and even. That's going to be -3, so that should be 6. So my coordinates should be 1, 6 when I'm done. If I go to this graph and I look at 1, 6, and I look at that point there, you should visually be able to see that, yep, this point Z, I have a quarter of the distance this way and 3/4 this way. It looks like I should be able to fit 4 of those lengths down that line, so it works out. So my answer is 1, 6. Okay, 2 more examples here for you. This one says, let's see, A is at -6, 4. So let me write that. A is at -6, 4. B is at 2, -4. Now this time the directed line segment is BA. So this time we're starting with B. Let me kind of highlight that. we're going to start here. This is the beginning because, again, the b is first. So for my x values, I'm going to start with 2. And let's see, the ratio is 5/3. So the ratio is 5/3, so the scale factor 5/8 is what I'm going to use. So to this I'm going to add 5/8. This time it's got to be -6 minus 2. It has to be end minus beginning. So it's 2 plus 5/8 times -8. So that's 2 plus -5 should be -3. For my y's, I'm starting at -4 and I'm adding 5/8. Again, it has to be the a value minus the b value because it's end minus beginning. -4 plus 5/8. This is +8. So -4 plus 5, that's +1. So that answer is -3, 1. If I were to graph these 2 points, -6, 4, and 2, -4, there's my line. This is B, this is A. -3, 1 is right there. I should have like 5 parts on one side, 5 parts on one side, 3 parts on the other side, so it kind of makes sense. The last one, A and H, I want to find point J, line segment AH, so A is the beginning, H is the end. I start with A, and 3:2 ratio, that means my scale factor is going to be 3/5, the first number over the sum. So again, my x value, -5 plus 3/5 of the entire way, 5 minus a -5, so -5 plus 3/5 times 10, -5 plus 6, that's going to be 1. For my y value, I start at 3, and I'm going to add 3/5. The difference is 8 minus 3, so that's a nice even 5 as well. 3 plus 3/5 times 5, 3 plus 3, and that's 6. So that last answer is 1/6. And that's all there is to partitioning a line segment. You just have to figure out where to start, get the scale factor, and then you follow this process.